Hello everyone, I hope you all are doing great. And today we will be discussing about content recommender, specifically video content recommendation engine. Here we will be actually making use of the semantic similarity around videos. And if I talk about traditionally how the video has been recommended to you so that you get to see the videos which you actually wanted to, is based on the metadata or the description or the keywords or transcription, or specifically the user interacting with that video, and you being with the similar kind of people who interacted with that video would like to see which video. So it's like on the basis of the interaction. But here we will be specifically talking around the video understanding so that what you feel, what you want would be provided to you or recommended to you based on understanding the video with the help of semantics. So this is powered by 12 Labs, and how the 12 Labs helps you here is this whole videos are being embedded with the help of Marengo Retrieval 2.7 model. And this has been stored in Qdrant Cloud collection, and it provides you the result quickly with the help of Qdrant search. So let's have a look at the demo, and then we'll have a look at the code and the architecture so that you can build your product with your data for your use case. So let's have a look. Let's say I came here and I just clicked on comedy. Let's say I just don't want to give any other such thing. So, oh. Oops, okay. Okay. So let's say I wanted to change it to fantasy and musical. So, so you can see it changes the vibe, but it's appended that in that sense. Second and then third. So 10 videos are being retrieved. I can say you can see your content. So let's have a quick new one. So let's say I just selected sci-fi, and here let's say dark tone. Okay, dark tone. Let's have a look. So here we can see robots, a kind of sci-fi, you can say. Here also. So yeah, you can see it understands very well about what you actually wanted to see, and that's why that it provides or recommends you the video, and it's how quickly it streams to you. So let's have a look at the code and how you can build it yourself, and it's so easy. So let's directly jump to the GitHub from here. Okay, so this whole application is built on Next.js with the backend on Flask API, and which has been connected with the CORS. So this is some of the pointer which you need to take care of. Um, and you can find all the setup information or the instructions step by step here of setting up the front end and the back end, and how to get the API key from the 12 Labs playground for the creation of the embeddings. And also you need in your application itself. So we'll understand how by breaking down the whole architecture into two parts, and also how to set up the Qdrant cloud, and it's super easy. So you can see here, you can just go to register for a cloud account with your mail. You just need to set up the cluster, select few steps, and in just 2 buttons, you get your clusters ready, and you can just get the API key from here and the host, and you can just connect it. So it's that easy. Like you can see, it's this much step only. So let's have a look at the code. So yeah, this is the whole overview of the application. So let's break it down into a two-part. Let's say this part is the first step, and this is the second. So first step is needed to get all your data, your video content into an embedding format, and it should be stored in a vector database. This is the initial step, and after that, you can start building your application. So what is happening here? Let's understand this. You have a lot of video, let's say 100 plus videos are being collected, and then with the help of the 12 Labs Marengo Retrieval 2.7, this video is being converted into an embedding. And if you have the public URL of that video, then it's fine. You can store it in a metadata. But if you don't have the public URL to stream it, okay, and you need to store it in the metadata so that you can make use of that. So here the strategy is, at the same time when the embedding has been created, the videos are being stored from locally to S3 bucket, and you get a public URL. So let's say there is one video which came, and the embeddings were generated with that public URL in the metadata, and clubbing it in a point struct. This is stored as one point in Qdrant, then the second point, then the third point. So this is how it actually works. and gets inserted into a Qdrant cloud. So we'll have a look at how this works, but let's understand the further steps. What after you have all the data in an embedded format into your Qdrant cloud collection? The next step is user come and provides the preferences and search, as you have seen while I was giving the demo. And then that text query or whatever the things which I have selected from the drop down are actually text, right? So that text query is been converted to embedding with the help of the Mengo Retrieval 2.7 again, but with the for the text. And then the semantic search happens with the Qdrant cloud, and you get a relevant content recommendation for you. And here, let's say I changed my preference or the mood search. Again, it goes to the model. The text embedding gets generated and the semantic search happens, and you get to see a new relevant content recommendation. So this is the how the flow actually works on. Let's have a look at the first one, which we discussed about. So for that, you can just go to backend API. And here there is a one easy notebook to follow on of how it works. So yeah. So what are the steps which will be focusing on is video to upload in AWS S3 bucket so that we get a public URL. Second is the embedding generation, and third is to store all this embedding plus metadata into a Qdrant cloud collection. So the few of the dependencies or modules which we'll be needing is the Qdrant client and Boto 3 for AWS and 12 labs. And these are just the same libraries which has been imported. And you need to configure your AWS SS key, secret key, bucket name. Okay, so next step is setting up the Qdrant client. Here, the timeout is 20 seconds in gRPC as first, and this is the two credentials which we need from the cloud cluster, which is the host and the API key. Now, the essential task comes is to upload to S3 bucket. So let's say you have a file path where all the files are there, video files specifically. You just need to have like this function S3 client.upload file, and you get your URL and you just return the URL. So it's that easy, okay? And then the crucial part is creating a video embedding. So let's say you provide a video path and your specifically your video path or specific video every time comes up, and it generates an embedding for you with client.embed.task. But here, one thing you need to make sure is your embedding scope is clip and video so that you get a complete video as a whole video as one embedding. So for that purpose, you need to mention this, and it takes very few seconds to generate an embedding for you. And then the third step is insertion into a Qdrant. So here it's just of getting the specific part of the embedding float in the video segment. And then here is the payload. You can see this is the vector, then video ID, then S3 bucket, the S3 URL, the public URL of that video, this true, and the original file name. And next, the last step here in this is now all the function we have defined. Now we need to call it at the appropriate time or the steps. So there is nothing much. It just checks around. Okay, this is the video file, and there is MP4. Then the step one is upload to S3. Then we have this result. Then creation of embedding. So you can see just calling it and telling it success after getting that. And then comes is insertion into store in Qdrant function, and tada, your everything is done. This is just an exception which you might can ignore. And also this is how you get your whole data frame kind of to get to know, okay, what all videos goes on and what all fail. And the reason to add this exception and this is because for the application which you seen in the demo, it have like 100 plus videos. So it is kind of bit time consuming for me to track down everything. So for that, it's used for management, but everything got embedded and uh, got stored also. So you just need to uncomment this and run. So this is how the first step looks like. Now the core functionality part comes in. Now the main API building, or you can say the core functionality utility building steps comes in. So let's have a look at the whole folder of the backend. Okay, and we'll also see how it interacts with the front end also. Sorry. So here you can see it's a Flask API. So Flask has been mentioned, then 12 apps, then Qdrant client, then .env just for the security purpose, logging so that we get to know, okay, what's going on behind Flask CORS so that our API should interact with the other portals which are calling that API. App scheduler is being mentioned here for the cloud purpose so that after hosting the API, the server don't gets to sleep. For that purpose, it has been mentioned. Yeah. So next step is just defining login or load.env. This is the most essential part of CORS origin. defining and also Flask app. And here we need these three credentials to get on. So API key of the 12 labs, which you can generate from the 12 labs playground. Qdrant host, you get it from the cloud cluster, which you have created on the Qdrant cloud. Then Qdrant API key from the Arrow itself. Then the collection name here, which has been provided, is content collection. You can name it with any name you like, which would be unique. Vector size is 1.24. And here is defining the client. So we defined the 12 app client with the Qdrant client, which we have seen in the last folder two for the step one. Now, this is just a server notification so that when the server gets run, you know it's running. So for that purpose, it's been defined server is running. Then we have initialization of the Qdrant so that if there is, to understand about whether there is a name of this collection with this name or not. If it's not, then create one. So for that purpose. Uh, this is just a health check. And now we came to the main function to discuss, which is the search. So how it works. It's so easy. You can just have a look at it. It just ensures there is the request which has been provided from the front end is exactly in JSON data or not, because we need to get the query data or the value which is being sent from the front end, right? So here it has been stored into a query. After that, after we get this, here is just a logger so that you can see in the command prompt as you get the exact original search query or not. Then this is just a formatted query on provider. You can just remove it or redefine it. And then the main task comes in is you just convert this text query into a text embedding. And for that purpose, we have defined here client.embed.create with Manigo Retrieval 2.7. And here the formatted text has been provided. And with that, here we stored the embeddings which has been there in the embeddings float in the text embedding into the vector. And here the main search happens. So what has been provided? Query points, which is search itself from the point, and then collection name is defined, then the vector is defined. Vector is the text query embedding which has been generated, then the limit of 10 so that we get the 10 exact videos which has been similar in that space. We'll also get the confidence score, and as per the most high confidence score will come at the first, so it depends on that. Okay, so here we get the response. It just does a JSONify, and you get the score and the video URL to stream on. So it just around structuring the output we got, and it just build the result object and it returns to the front end. So yeah, it is that easy. You see, it just the backend got over. Yeah, it just initialization of Qdrant. This is just a wake up app for the render. And yeah, it's done. So let's have a look at the front end to understand on how it calls. So let's quickly go to this and app. So the first page, which you can see here, the first page, this is in the uh, this is the page.tsx, but we are in the explore page, right? So as soon as you see the explore page, so you can find it here, and we'll be discussing mainly this only. So let's say I just search around sci-fi. Wait a second. This is the fallback part. And yeah, here you can see all these select items which was being mentioned, which I selected from, is mentioned here. And if I just search around the main function as handle search, yeah. So here you can see handle search takes on the category description and the category and specifically the query which you provided. So if you have seen, I selected a sci-fi category and then the dark tone. So dark tone was my query, and this was the full category text which has been there. And then it sends it uh, to the front end. So specifically, if I show you the specific function around it, yeah. So this is the process.env.next public URL. So at this space and slash search, this space you can just replace it with localhost 5000 for the Flask API, or if you have deployed this API, you can provide that URL specifically here, and you can access it. So it's a good practice to define the process.env.next public URL so that you can change it in the env, not here, so that your production doesn't get disturbed in this case. So here in header and the post method, you can see in the JSON format, the query is been provided and the backend response status has been provided here. and then the data has been received from the backend, and after that the processing and getting the video URL for the streaming happens here. So that you can see after clicking on the video player, it just changes every time. So here the processing happens. But let's say the API failed or something happened, then the fallback method has been added so that it doesn't provide the error to the user, and it will go to the fallback part. So if I can show you, the fallback part has been defined at the start. So this these are the category fallbacks, and these are the general fallbacks. So if something goes wrong, it will just provide me this stuff. So this is also good for the debugging purpose, so that if something goes wrong and you get the relatively this particular video, then you will get to know, okay, something is going bad. So this is one of the way of getting to know of if something goes bad. But you can see it's that easy of how it actually interacts, and other stuff in this is mostly around the front end. So we are basically more of an interest into discussing around the core functionality of how you can build around it. So you can see how easily it works, and also mentioning of a bot signal so that you don't wait for such a long time. So yeah. If we just discuss around a bit of an diagrammatically of how actually the search works. So we'll have a look at, or have a glance at it at this. So here the user provided a search query or preferences as funny animated clips. First step. Okay. Second is the post search query, which we have seen at the search endpoint. Then we get a text embedding of the query. The generated embedding has been provided. After that, the vector similarity search with query embedding happens, and then we get the matching videos with the metadata score, and then the JSON response with matching video is been provided, the display video with metadata so that we get the video URL specifically, and then the user gets to see the relevant videos. So yeah, that was the whole application. You can check it out, you can contribute to it, you can build with your data and do the experimentation. So yeah, uh, thank you.